Hello everybody, we are going to fix some boards today. We're going to have a Fiesta. I've got a big stack of iPhone 6s that are all dead logic boards that are sent to us from a wholesale refurbishing contract. So we're trying that out and we're going to see if we can fix some of these. We're going to take this opportunity to show you what it looks like to kind of troubleshoot a dead no power board. So that is going to be a lot of DC power supply work, so let's get started. Here's board number one. Board number one. All right, let's see. Now, none of these really have very much information with them other than dead. So rule number one, you don't have a board problem until you know that you don't have a parts problem. So rule number one on these has already been done. So all we know is that it did not power on in the hands of a professional refurbisher with their known good parts. So that's all we know about these. So let's look to see if there's any signs of water or any signs of trauma, bend, drop, anything that kind of jumps out at us. And so far, it's kind of odd that they left the little bracket in the camera on these. Let's pop that off so that we don't end up destroying the camera because of heat on the board. All right, so let's start out with a dead no power board. Let's see. There's an echo, echo, echo. Let's see. Is there two different audio captures going on here? Here's the microphone. Here you go, buddy. Come on over. There we go. Microphone. And take out that audio. That's anything else that's audio, desktop audio. Let's see if I do that. Audio input capture. Does that make that better? Let me know if that makes that better. Hi, teacher of madam. Teacher of madam. All right, so I don't see any reason why there would be an echo. I think earlier it was capturing like microphone from the computer as well as the main microphone. Better. All right, great. I think that turned itself on with my scroll wheel. Okay, so let's start with the DC power supply and see what does it say. Echo gone. I have a buzzing. I don't hear any buzzing in here. So that is all magic with low pass filters and things like that that I never... High-pitched whine? Let's turn that down. Is that better? Maybe? I turned the audio input capture down, so maybe that will help. All right, let's get started. We are going to connect the DC power cable, and now I will only be able to see it up there, same as you guys. Mic too close to power supply. Well, mic is on a very short cord. That's probably the best I can do. All right, let's get a dock and prompt to boot and see if this has a normal or abnormal boot sequence. All right, let's see. Can't hear anything now. All right, let's make it be this. Something in the middle. That. We can try that. Okay, so I've connected a dock and DC power cable. So we're going to plug in USB to prompt to boot. So when we prompt to boot with USB, here's one of those things. The device is naturally going to want to draw current from the 5-volt USB supply to save the battery. So it will not draw as much current from the battery while I have USB plugged in. So what I'm going to do is I'm going to use the USB as a prompt to boot, and then I'm going to take it back out so that we can see the current consumption on this. There's interference from something. Volume very low. Let's see. how about we change audio capture to microphone capture. All right, let's give that a try. Okay, so let's prompt this to boot then and see what happens. Connecting, connecting, connecting. And now we can see that boot signature. So we can see those numbers changing. And we're going to try to make sense of it. So that boot signature, so I want you to look here, look at the DC power supply. And it does seem like it's a little higher than normal. Some of those numbers are going up almost to 2 amps, and that's a little bit abnormal. Then it seems to be settling down. That boot signature is normal enough that it makes me want to put a screen on it and see if it actually can boot with a screen. So let's do that. Play back the YouTube live feed to yourself and you'll hear it. Buzzing, it's crazy, voice very low. Alright, gonna watch this after the fact. Alrighty. There's only so much you can do when you're on the clock. It is my anniversary today, and I gotta get out of here. But I wanted to just kind of go through some of these. If it doesn't work out, other option is to just say, forget it, and I'll just fix these by myself and then go home. Alright, let's see what happens if we plug it in. With a screen on it. Alright, so I'm prompting it to boot. Prompt, prompt, prompt. We're going to let go and watch that DC power supply. And on this one, you can see that it is starting to boot. It's got a display and backlight. So let's watch those numbers. And let's see. Now this one seems to have a bit of an image defect. I don't think I'll be able to show that to you. Maybe under the microscope it might pick it up. It seems to either, I'm going to swap out this screen. I don't think you'll be able to see that. Yeah, you can see it. See how there are some very thin horizontal lines in the display. See these thin lines? So that's either this LCD or that could be a defect. Yep, so this definitely is not a normal image, which is a clue. So I'm going to swap that out and grab a different screen and see if that helps. All right, let's see. So I've got a big pile of 6S screens. Let's give another one a try. And we'll see if rule number 1 applies on the screen or if there's actually a problem. Let's see. Buzzing bad. Don't know what to do about that. Can't think of anything that is different other than I changed the input to a, I don't know what microphone. Prompt to boot, prompt, 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 and letting go. And this screen has nothing on the display. So let's swap that out and try a third screen. I can try and just sort of disable this audio input and add it back while we wait for this one to boot. So I'm prompting to boot again, prompt, prompt, prompt. And that image seems fairly normal. Let's go ahead while that's booting up and let's see if we can get rid of an audio input. Let's see. Add audio input capture. Microphone. And let's get rid of these other ones. All right, so give me a shout on how that works. So I've kind of taken off the other audio inputs and added back the main microphone. All right, so let me know if that is better or not. Worse. Well, that might be all we can do. This is, I don't think anything's happened to this lately. All right, beeping louder. Is my microphone dying? Should have bought the microphone from Amazon and not the one that Lewis made me buy from some country that didn't ever have the right adapters and it never worked. All right, so now this phone it has booted, so we can see it booted to the lock screen. So let's try to guess. Why is it here? Why is it here? So this paper says caliente, which I'm guessing means that somebody thinks it's hot. So let's see if it's actually hot or not. We'll use whether or not it's hot, we'll use the good old-fashioned face test. Highly recommended. All right. Seems a little bit hot near the top of the board. All right, so since it's a 6S and it's here because it's hot, and we know that 6Ss have a tendency to get some partial shorts out of the blue in an otherwise good looking board. Let's take some diode mode readings on backlight and image lines and see if any of those are just a little bit low, especially because we did see kind of an image defect on one LCD. So let's take a look. Let's check out backlight. So in diode mode, our backlight line is 0.499. That's normal. Now let's check our image power line, our 5V7 image power, and it's 0.548, which also seems pretty normal. All right, let's take off this back sticker and see if we can see anything there. Did you try unplugging it and plugging it back in again? You almost fixed the buzzing sound when you play with the mic. All right, what if I do? Then I can turn this button all the way up on the mic. Don't know what that button is for. Let's turn it all the way up. All right, I turned it all the way up. And I pushed the button again. I turned it all the way up. Let's get this sticker off. All right. Everybody says no sound. I think sound. Beeping still there. Beeping. What is beeping? What is beeping? All right, let's see what our VCC main voltage is here in diode mode. We're going to check the resistance on that line. All right, let's turn this blue button all the way back down. I wonder if this cable got soldered or something. Let's turn the button this way. See what it does. How about that? That's RF noise. I don't hear any noise. I think it's perfectly, deliciously quiet in here, actually. All right, VCC main diode mode reading is 0.313, and it's coming up because I used a little bit of heat. So that is not really super low. Plus, there is no leak of current. So I think that's going to come back to normal, 0.318. So that is probably not it as well. So this one of the other things that can happen with an iPhone is that's kind of getting hot. That can sometimes be software where the way the applications process, which is all software, can change over time, and with software update that can make a phone that is kind of running hot, seems hot, will suddenly be totally fine. So let's look at that current consumption again with this screen on it, and if we don't see anything that's jumping out at us to fix, then we're going to move on to the next board and put this one in the rule number 1, parts and software. All right. Leave the hot air station on. It masks the buzzing. Okay. All right, so we're gonna, oops, let's prompt to boot with the DC power supply. You can leave the hot air station on. If it sounds better to have a hot air station on. All right, prompt, prompt, prompt. And let's watch these numbers. So we're watching these numbers, and we're looking to see whether or not they look abnormal. And right now they don't. That looks pretty normal. If it gets up close to 2, then I would say that's abnormal. Alright, so it has booted, it has touch, and I cannot find enough of a defect. It's unclear whether or not this has any defect at all. So we're going to put that one in this board is not really telling us where it hurts at all. Alright, let's grab the next one. Let's see. Hey Jessa, hey guys, how are we today? Does that power supply have a fan on it? Yeah, but it's pretty far from the microscope, and it's pretty much always here, and it's always in every stream. The fan might be pointed more towards the microphone, but I can't really move any of that. So I'm trapped with that. Okay, let's do the next board. Next board. Let's start with visual exam. Let's also get rid of the camera. We make a little collection of cameras. Alright, looking around, does anything jump out at us? So this one is missing the gaskets here. So that kind of smells like prior repair attempt for some reason. Somebody has come here before and looked around and taken these gaskets off. This looks a little hot here. This looks a little suspect. This, I think, is something that I would want to point out. See how we have signs of heat. Signs of heat on the side of those caps, especially this one. Look at that. That is what happens when you apply heat to a chip that has underfill, and that's generally a bad idea. And it kind of points to an idea that maybe someone at some point put just kind of general heat on the NAND, and then that kind of matches with, there's a yellowness, a discoloration on this SIM tray. So that kind of implies that somebody just took something with heat and went like this at some point in time. Who knows why? Not a good idea. We'll kind of keep that in mind. And that can also bother chips that are underfilled, that are nearby. So let's scrape off the sticker and check under this one. Okay, yeah, so this is a great little story here. Look at this. This is a great story of your visual exam. Look at this. See the Mickey Mouse ears on these components. That is bad, bad news. So these little balls, and let's look at the area. There is, wow, there's a total bridge right there. But let's look. So we see that kind of hint by the NAND of excess heat. A little hint that made us say, hey, let's look under the sticker. And as we look around in this area, we can see signs of heat. Look at this. These are two VCC main caps that are now totally bridged together. We can see these two caps are bridged together. So there is signs of heat all the way around the underfilled PMIC. What a way to destroy a phone. That is sad. So on this one, there's no heat anywhere else as we look around. So this means someone intentionally put heat. Listen to a 1 kilohertz audio file, then you know how it sounds. I get it. If you don't like it, don't watch. There's nothing that I can do. In fact, let's just stop this stream. Too much complaining about audio. Nobody can participate. And